All right, we're back. We are on page 6 of notes 20 of Calc AB. We're doing areas of regions bounded by curves. It's like a fundamental theorem application type thing. It's really one of the things I think of when I think about calculus is like, how do I find the area of this region? And it's like, oh, you just do an integral. All right, so one of the things you do a lot of, maybe not like in the quote unquote real world, but in the calculus world, is you're always finding like a way to split a region in half or in some other like weird ratio using either a vertical line or a horizontal line. So let's take a look at some of these and just like see if we kind of understand what we're talking about. So find a vertical line, x equals k, where k is between 0 and 2. Splits a region bounded by y equals x squared and y equals 2x exactly in half. All right, so let's start off with a picture and get a sense of what we're talking about. So picture, it's like I waited for it to become a line and then I didn't make it a vertical line. Okay, so x squared, maybe like this. And then y equals 2x, maybe like this. So we want to take this region, these they intersect it too, but 2x, x squared minus 2x equals 0, x minus 2 equals 0, x equals 0, x equals 2. If you got to do the math, you got to do the math. There's 2. All right. So like you might just guess that it's at 1. I don't know. I mean, that might actually be right. I don't know. If we cut it here, do we get the same area here as we get here? That's like the question that we want to answer. So what I'm going to do is I'm just going to take like a sort of arbitrary line. Like there's no real rhyme or reason to it. I'm going to say I think it's like here. And I'm going to say this is x equals k. And the idea is the area of the region to the left, this region, should be equal to the area of the region to the right because we're splitting it exactly in half. So those should have the same value. So we can set up, there's a couple of things we can do. Option number 1 is, and I think option number 1 makes like a lot of sense. So I'm gonna write it here and then I might pick it up and move it. Option 1, if I just do the integral from 0 to k of top take away bottom, so 2x minus x squared, that should be equal to the integral from k to 2, right, of 2x minus x squared. That should totally work, right? Now the issue, it's not really an issue, but the pain in the neck is that k is a bound for both of them. So like we're gonna get an equation that has k on both sides and then we have to solve it. So I'm gonna do it, but I'm just saying like I'd rather not do it. So let's see, this is gonna be x squared minus 1/3 x cubed from 0 to k. At least there's a 0. And then x squared minus 1/3 x cubed from k to 2. So we get k squared minus 1/3 k cubed equals, so plug in 2 and you get 4 minus 8/3. Then plug in k, you get k squared minus 1/3 k cubed. Okay, so if you kind of like you get 2k cubed minus 2/3 k cubed equals 4/3. Let's multiply by 3, and that'll get us 6k cubed. How come everything's cubed all of a sudden? You're not cubed, you're squared. Okay, 6k squared minus 2k cubed equals 4. So now 2k cubed minus 6k squared multiplied through by a negative equals -4, bring it over, so plus 4 equals 0. And now you have to solve a cubic, and that's fun. K cubed minus 3k squared plus 2 is 0. You can just guess that k equals 1 works. K equals 1 for sure works. And then if there's more values, there's no way that they're between 0 and 2. Like they have to be between 0. The answer has to be between 0 and 2. K equals 1 works. There's no way any other answer is between 0 and 2 that's going to cut this region in half. So what can happen, weirdly, is you can get a value like out here where like, because the top and the bottom switch, but you didn't switch top and the bottom, you start accumulating negative area, and then eventually the negative area like gives you an answer that kind of works. I'm gonna do that on the calculator. Well, potentially do that on the calculator and show you. All right, that's option 1. I didn't particularly like it. I'm gonna now do option 2. So option 2, what I'll do is find the whole area, and then say that the integral from 0 to k should be half of that. And so that has only 1k in it, and so it's a little easier. So option 2, I'm going to do the integral from 0 to k of 2x minus what? X squared should be equal to half of the integral from 0 to 2 of 2x minus x squared. And now the question is like, do I want to do this? Like, I definitely don't, but I actually already know this one. Let's just borrow this answer from here, right? So that's k squared minus 1/3 k cubed. K squared minus 1/3 k cubed equals 1/2 of, so this is x squared minus 1/3 x cubed from 0 to 2. When you plug in 0, you just zero it out. So it's 1/2. 4 minus 8/3. So that was 12/3 minus, so 4/3. Half of 4/3. K squared minus 1/3 k cubed is half of that. So 2/3, 3k squared minus k cubed equals 2. Which, like, is this the exact same equation that we got? It is, right? Multiply through by a negative, you get k cubed minus 3k squared equals -2, but bring it over, equals this. And lo and behold, same equation drops out. I think it's a little easier to do option number 2. I'm gonna use a calculator, and then we'll just do this problem in this video, and then I'll come back and like try to do these problems in the next video. Let's see. So switch to a calculator, and let's see what our options are. So doc 4, I'm gonna insert a new problem. I'm up to a lot of problems. Problem 7. All right. So I could have done, I'm gonna use solve. I'm just gonna see what happens here. Menu 3, 1, the integral from 0 to k of 2x minus x squared dx should be equal to the integral from k to 2 of 2x minus x squared dx, and I need to solve this for k. So you can see I've gotten 3 values, 3 kind of weird values. Well, the one makes sense. K equals 1 is the only option that like really works. So what's happening is you get like these weird-ish answers, I think. So let me do I don't know how best to illustrate this. But do this such that k is equal to, let me get the exact value. K is equal to this. Gives me 2/3, which is exactly half the area. And then if I do, I guess this one, such that this is the value, and double that. You get 2/3 both times. Let's look at the graph. I'm trying to, in my mind, work out like how best to illustrate this. And then x squared. Okay, so I'm gonna do the bounded area thing. Oh no, it's not gonna, I think it's not gonna work here because the bounded area is like too smart, right? And it's gonna do something funny. So also I didn't mentally note that value. 1 minus √3. So 1, click. There's only 2 graphs, so I don't know why that happened. 1 minus the square root of 3 is the lower bound. And then the upper bound should be, oh, you know what? That was actually supposed to be the upper bound. So can I just do to 0, and then we'll know that it's the negative of that? why did it make that? Oh, well, because that's what I told it to do. I'm gonna undo that. Okay, let's do it again. Menu 6, 8. By the way, I don't think this is gonna work. I wanna go from 0 to 1 minus the square root of 3. And it still gives me positive. Why are you giving me positive there? It should give me a negative. I don't know, I'm not gonna be able to illustrate this because of that. But look at this region that we found. The region that we found isn't even, it's not even in the region. It's not between 0 and 2. It's like some weird thing. So like that's obviously not right. Well, I think. And then the other region that we would do is, so that's 2/3. I'm gonna undo again. And then let's do the other one. So the other one would be menu 6, 8. The lower bound is 1 minus the square root of 3. And then the upper bound is 2. And so this gives me 2. I don't even know what's happening. Whatever. Those are like extraneous solutions. They don't make any sense. All right, I'm gonna go back to the notes. Terrible exploration. We got our value though. We got that k is equal to 1, which is probably what you would have guessed anyway, but like, can't always count on your guesses. All right, so I'm gonna stop this here, and I'll come back in the next one and do the rest of the problems, or at least give it a shot. So I will see you there.